Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on metallurgy. In our last lesson, we discussed the phosphorus cycle. We learned that phosphorus is not found in a gaseous state in the Earth's atmosphere. It is found in water, soil, and sediments. We learned that during the phosphorus cycle, phosphorus is released into soil or water where it is absorbed by plants and animals. When plants and animals die, they decompose and release phosphorus back into the soil. We also learned that the phosphorus cycle can take millions of years to complete. In today's lesson, we are going to define metallurgy. We will also explain the major steps in the metallurgical process and focus on a few steps, including concentrating the ore, pre-treating minerals, and converting minerals into elements. Let us get started. Metallurgy is the science and technology of extracting metals from their natural sources and preparing them for practical use. The principal steps that are carried out to obtain a metal from its ore are concentrating the ore, pre-treating the ore, extracting the metal, and refining or purifying the crude metal. Concentrating an ore is a process by which the amount of metal-bearing ore is increased and most of the accompanying rock and soil is eliminated. The accompanying rock and soil is referred to as gann, and it is an undesirable material or impurity. Once ore is crushed and ground, the gann can be removed in a number of ways. Let us go through them together. Gravity separation can be used to separate gann from ore. This method depends on the difference in density between the mineral and the gann. For example, gold can be separated from gann using gravity separation because gold has a very high density. Magnetic separation is another process used to separate gann from ore. This is mostly used to separate ferromagnetic minerals, which are minerals that can be permanently turned into magnets. Mineral magnetite is one example. Ore can also be separated from gann by using froth flotation. During froth flotation, finely ground ore is added to water that contains oil and floating agent. Because of the different surface characteristics of mineral and silicate rock particles, only the mineral particles are wet by the oil. Air that is blown into the mixture causes tiny bubbles to form on the mineral particles. Then they float to the surface where they are skimmed off. Amalgam is an alloy of mercury with another metal or metals. The amalgamation process can be used to extract metals from their ores. For example, mercury dissolves silver and gold in an ore to form a liquid amalgam. This is easily separated from the remaining ore. The gold or silver is recovered by distilling off the mercury, which we will talk more about in your next lesson. The final method used to separate ores from GAN is leaching. While the other methods we discussed are physical, leaching is chemical. The ore is treated with a reagent that dissolves the target substance. The impurities are left undissolved. Students, let us do an activity. Name the 5 different methods used to separate ore from impurities.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. If you said gravity separation, magnetic separation, froth flotation, amalgamation, and leaching, you are correct. Let us continue our lesson and talk about pre-treating minerals. Pre-treatment converts a mineral to a form that is easy to reduce. For example, sulfides are converted to reducible oxides by heating them in dry air. This process is called roasting. If a metal is going to be obtained through electrolytic reduction, its oxide hydroxide or carbonate is often treated with hydrochloric acid to convert it to chloride. Chlorides are preferred for this type of reduction because they often melt at low temperatures to form conductive liquids. Since metals always have positive oxidation numbers, when they are in their combined form, the production of a free metal typically involves a reduction process. This process depends on the standard reduction potential of the metal. The production of metals by reduction can be done either chemically or electrolytically. Let us discuss both. During chemical reduction, a more electropositive metal can be used as a reducing agent to separate a less electropositive metal from its compound. This is done at high temperatures. Less electropositive metals are obtained by reducing their oxides with carbon at high temperatures. Carbon is used because it is cheap and plentiful, but it cannot be used to reduce all metal oxides. If hydrogen is higher than a metal in the reactivity series, it can be used to reduce that metal. Hydrogen is expensive, though, and it is only used to extract tungsten on a large scale. Electrolytic reduction is used for highly electropositive metals. Students, name a metal that is obtained using this method and explain how this is done.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. You might have said that aluminium is a highly electropositive metal that is obtained using electrolytic reduction. It is extracted by the electrolysis of molten aluminium oxide with cryolite. Cryolite is added to aluminium oxide to enhance electrical conductivity and to lower the melting point. In today's lesson, we defined metallurgy as the science and technology of extracting metals from their natural sources and preparing them for practical use. We also discussed the methods for concentrating the ore, the purpose and process of pre-treating ore, and the two methods used to extract the metal. These methods are chemical and electrolytic reduction. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.